Anna, I see you're up to physics again.
Hi, let's go over a really great physics problem for your OAT exam. We have a large container of water, and it has a sphere of unknown material submerged 2 meters below the surface, and it's stationary. Let's have a look. We have the sphere. Notice this is point Q, this is R. From here to here, the whole diameter of this sphere is 2 meters. We're 2 meters from Q, and we're 1 meter from R to the bottom. And it's all drawn for you. The pressure of the atmosphere is 1 to the 5th newtons per meter squared, and that's given. Okay, let's do it. Let's find the pressure at Q. The pressure at Q is going to be equal to the pressure due to the atmosphere plus the pressure due to the fluid, since it's submerged. Well, let's go in. Pressure of Q at Q is 1 to the 5th. That's the pressure of the atmosphere. The pressure of the fluid, and that's the formula you need to know, is dGH, where D is the density. The density of water, if you remember, is 1,000. G is a constant. And as you can see, the distance from the top, Q is 2 meters from the top. We put it in, we got 119,600 newtons per square meter. How about finding the pressure at R? Well, it's a little deeper now, so we know it's going to be greater pressure. Pressure at R is the pressure of the atmosphere plus the pressure of the fluid, same game. We know the pressure of the atmosphere, pressure of the fluid is dGH. The H this time, as you can see, we're 2 here and 2 here, that gives me 4, and we get 139,200 newtons per meter squared. What is the buoyancy force on the sphere? Notice it's submerged partially, so there's a buoyancy force. Buoyancy force is equal to dVg. Well, what's the volume of the sphere? That's the tricky part of this. You had to know the volume of the sphere is 4/3 pi r cubed. There's the 4/3, there's the pi. We know the diameter of the entire object is 2, so the radius is 1. The numbers on the exam will be nicer, but that gives me the volume is 4.19 meters cubed. And there we go. We know the density, we know the volume of the object, which is also the volume of the fluid displaced. We know G, and we get 41,062 newtons. Find the weight. Well, a free body diagram reveals the answer. You have the mg, that's the weight, going down. The buoyancy force goes up. Notice it's stationary, so the buoyancy force is equal to the weight. Buoyancy force was 41,062, so that would also be the weight of the object. Simple. Okay, I hope this gives you an idea of how to approach these problems. But never forget, whenever you're dealing with pressure, you have to always take into account the pressure due to the atmosphere, unless, of course, it's a closed container. But if it's open container, and this was open, you got to also consider the atmospheric pressure, as well as the pressure due to the fluid.
Dr. Romano, is that Felix the cat on your shirt?
It is, Felix. Good day to you.
Well, Dr. Romano, I'm a little tired. I'm taking a break. Felix the cat? Wow.